This is Audiomunity, a podcast about our body's never-ending fight with the outside world.
Sometimes you get lucky. Sometimes you get lost.
Hello, everyone. This is Audiomunity, episode 49, recorded on November 18th, 2025. I'm Kevin Bonham, joined, as always, by Matt Woodruff.
Yeah, actually have a face this time.
Yeah.
Made the video work. Showed up early
wonderful
to get that done.
Good for you. I realized when I was editing the last one, we said the disembodied head of or voice of Matt Woodruff, but for people that were listening on audio, they had no idea what I was talking about.
That's true.
So continuing from last episode as well, we're excited to have a guest join us today. Dr. Nicole Ackermans is a assistant professor at the University of Alabama. Hi, Nicole.
Hi, thanks for having me.
Yeah, absolutely. And the paper we're going to discuss today is quite a departure, I think, from our usual fare here on Audiomunity. And just to give people a little sense behind the scenes of how we... how much care we put into choosing papers. Nicole, I saw you share this paper on social media, and I read the abstract, and I was like, this is fucking cool. Is there any plausible link to immunology? And you said, neuroinflammation?
Yeah.
Question mark? And I was like, good enough. We're going to do it. But I have to say, after actually reading the whole paper, I think it actually is quite relevant, and there's a lot to talk about that I think is of interest.
Good.
So I'm excited to chat about this.
Yeah, and I actually can verify. So I've pulled up the text message that I received from Kevin, and then it says it's got a link to your paper, and it says very tenuous link to immunology, but I think it's fucking rad. So
Nice,
that is how we chose the paper today.
High
and
praise.
It's so delightful to have you here. And Kevin and I realized we haven't had a what's new in science 2025 recently.
Yeah.
And Nicole, this has been a segment, somewhat recurring segment, just really talking about what's good in science in 25. And the answer
typical answer is nothing.
Not much.
No,
Not
come
much.
on.
It's been a bit bleak at times. Unfortunately, we were just discussing before the show started some of the hits that we've been taking in our programs around. I want to say that this is good in science in 2025. I really enjoyed reading this paper specifically
thank you.
because it was like. It was definitely outside of our normal topics of conversation, but also the care that you took to like go back to ancient Greece and talk about some like history of science here. Like it did read certainly like a scientific review as you got towards modern history, but I would really encourage, I never know how much of our listenership actually goes back and reads the paper, but
I can track that.
It was a lot of fun to read this. It was a really nice sort of light way, I think, to enter into science this week. So I really appreciate you taking the time to write this.
Thank you for all the praise. I'll take it. Like you said, there's not too much good news these days. So
no, we'll take it.
So we should say what the paper is. So the paper, it's a review article, and it's the title is A History of Thought on Brain Injury in Head-Hitting Animals. And the authors are Nicole Ackermans and Nicole Ackermans.
It's just me.
So it's just you here. And it really is a history of thought. I mean, like Matt was saying, it's quite remarkable just how much there is here. And Matt and I were discussing a little bit before we started recording, before you joined, that it really feels like you're sort of in this field and you're seeing some nonsense get talked about, and you're like, okay, if you're going to make a claim, you should like show evidence.
Yeah.
Let me just give you all of the fucking evidence.
And really, my first thought was, who said this? Like, where does this come from? And I just kept going further and further back like ancient Greece.
That's so funny you said that, because our conversation, my conversation with Kevin this morning was, you know how somebody says a thing and you're like, that's clearly obviously wrong, right? And so the first thing that you do is like, you write an email to that person, right? And you start with like that first 3 paragraphs, and it's usually like really snarky, right? And oftentimes I don't send that email.
Oh, this paper had a hate draft, for sure.
But then sometimes you're like, actually, what I'm going to do is turn this into a 20-page document, right? And I loved that. And I
mean, how much science is done out of spite? Most of it.
a lot. And I wonder how much of it is centered around the Q collar coming into reading this paper.
So some of it, that's not my personal vendetta.
Okay.
It's on the list, but I have a colleague. You noticed in that Q-collar paragraph, there's a colleague who wrote like 4 or 5 reviews about it. Smoglia, I think is how you pronounce it, James. And so that's his vendetta, but I've been roped into it because he keeps emailing me like, this is insane. And I've read the papers that make up this work, and I've talked to people who have worked with the person who made this work, and it is nonsense. Like, I really hope this guy doesn't sue me one day for defamation, but like...
I mean, you brought receipts in this paper.
Yeah.
But so
I need people to know.
Let's maybe back up a sec. So before we get into the structure of this review, I think it's worth sort of going through the way that you structured it. It's quite quite readable, and like it's got a nice logical organization. But just like, what is your background? How did you get interested in headbutting? Your social media picture is you holding a skull of a ram with big horns.
Behind me.
Nice. There it is.
So on video, and there's a woodpecker too. I saw as well. Is that a? I'm trying to get into birding. Is that like a pileated woodpecker or something?
That is let's say that's a hairy woodpecker decoy that we 3D printed for.
Oh, nice.
Actually, I'll just leave it in the background. How about that?
Oh, nice. Cool. So how did you get into this?
As with all these stories, it's convoluted. Okay, and COVID has to do with this story. So my background is in evolutionary biology, more anatomy, vertebrate morphology. I kind of, in my PhD and master's, was trained as a pure vertebrate anatomist. For my postdoc, I really wanted to work with this famous anatomist called Joy Reidenberg. She has like PBS shows. She was like my idol as a kid. And so I like cold emailed her because I had recently heard her on a podcast. I don't know if you guys know Ologies, but she was on Ologies. I also have an Ologies episode. And she was saying,
put a link
like,
to it in the show notes.
Yeah, please do. She was saying like, I'm thinking about like headbutting. And I was like, well, I know stuff about sheep. I guess I could work for her. And she just said like, get funding and you could work for me. And I did. Anyway, our plan was to go to the Rockies, record bighorn sheep, figure out like, why don't they get brain injury through anatomy? Except it was 2020. All the parks shut. We weren't allowed to travel. And so we were like, well, now what are we going to do for my postdoc? And my co-PI was a neuroscientist. By the way, I like hated neuroscience before this. I was like, that's for snobs, which it still kind of is, honestly. But and he's like, well, I have some bighorn sheep brains in my fridge, actually. So why don't you just take a look at them in the meantime until this like 2-week, illness is over? And
that's a little bit random. Let me just say, it's a little bit random to have a colleague that has bighorn sheep brains in their freezer.
He has. So this is someone this is Patrick Hoff. In his heart, he's like an animal brain scientist, but that doesn't pay the bills. So he works at Mount Sinai, where we were in New York, that human brains pay the bills. So he does his human work, but he's got whales, he's got chimps, he's got elephants, he's got bighorn sheep. So he just kind of knew a guy who worked at a zoo and who like donated all their brains. And so he has this great collection. And so I was like, all right, I'll look at this, for my postdoc. And summarizing it now feels crazy because it took me a year to figure this out. But we found evidence of brain injury, and we weren't expecting evidence of brain injury. And we went, oh. And it was like compare it to early CTE in a football player. Like, if you saw this in a human, you'd be really, really, really concerned.
Yeah, CTE, chronic traumatic encephalopathy.
Sorry, yeah. So what? Yeah, like repetitive head injury that's degrading the brain. And so we were like, oh, and that was kind of my big paper, like, hey, they get brain damage, and actually evolutionarily this makes sense because, you know, they have these big headbutting fights, and it was bighorn sheep and musk oxen, which are just big headbutters, and you got to have a loser. And yes, they don't drop dead when they headbutt, but they just need to survive long enough to reproduce. Doesn't really matter if they have a little bit of brain damage. Like my for some reason I got coded saying they don't have to do Sudoku puzzles. Like, it's kind of true. Like, they just need to reproduce, eat grass or whatever, and that's it. So
you're saying limited needed function after the headbutting.
That dumb, but like they don't also live that long. So who cares
Right.
if they get brain damage? It would be actually more quote unquote work evolutionarily to make them immune. And then came this whole idea of all the papers that I've read are people saying like, yeah, they're immune to brain damage. And I'm like, who's saying this and where's your proof? And then this paper's been in the back of my head for a while. And then last summer I got really depressed from all the like bad science news, and I was like, I'm just gonna do a project that is fun. And so I wrote this over the summer and had fun with it, clearly. And like I said, there was a hate draft. The first draft, my partner read it and he was like, you can't publish this.
I have to say,
It's kind of remarkable to be clear. Like, this is the not hate draft.
Yeah, that's the nice
It's
draft.
still-
I was just about to say, because you did a good job. It reads like a scientific paper, but there is an entire page dedicated to scientific snark around woodpeckers, and it was my favorite page. I think it was page 13.
I couldn't help myself.
I loved it. It. You basically just summarized the back and forth between a bunch of people arguing about why woodpeckers
I think it's
don't
8
get brain.
papers.
It's amazing.
And I was like, people need to see this because people love scientific drama. And I love that this was in the 70s. And people are like, dear sir, you are incorrect. And I was like, people need to see this exchange because it's hilarious.
Yeah, no, it's wonderful. And I would say, you know, full disclosure, we did go back and we found the grant that you wrote and submitted on bighorn sheep. And I think one of the remarkable things is to watch the progression of your language from when you wrote that grant.
Damn,
to
you
this
guys
paper,
did go deep.
Which was basically like, hey, so it's well known that bighorn sheep don't get, and then you're like, but whoa, like what actually happened there? So no, it's great to hear the story behind how that developed, and just cool. Cool. I'm glad you found bighorn sheep brains random.
Yeah,
totally.
Just random coincidence.
So the first several pages of this review are about history, and there's some like wonderful images pulled from like cave paintings circa 1000 BCE.
10,000 even.
Oh, okay. Figured. Oh yeah. Wow. Carvings, eliminated manuscripts, like stuff from the Bible. I think I saw you have a tattoo of one of these images. Which
Figure
is cool.
4.
Yeah. So I don't think we should go through all of the like ancient history, but do you have like your favorite or one of your favorite pieces of this history?
And
that you think
the way this came about, right? I was like, okay, so these guys, as in like early 19th century, keep talking about the immunity. Is there, like, how long have we thought about this? And I will say, I'll give a little bit of credit. My partner's an archaeologist. So I was hanging out at his job, and he works near Mesa Verde National Park. There's a lot of ancient Native American, Pueblo Native American, like, art around there. And headbutting bighorn sheep are common in sometimes pottery, sometimes cave art. And I was like, okay, well, clearly around 1000 BC, we were thinking about this. How far can I go? And in this kind of cave engraving of the 2 ibex headbutting, which is in Le Roc de Serre in France, which is that 10,000 BC one, the archaeologist who describes the art, I don't know if you've had the chance to see one of these, but it's mind-blowing how artistic it is, where it's built so that when you go with a a torch, like with fire, and you move, the figures look like they're moving. And I've been lucky enough to experience this. And the way that the archaeologist describes this is that because of the way it's sculpted, you can see that there is a strong physical impact between the two animals. 10,000 BC, they were thinking about this and presumably hypothesizing about it enough to, put a lot of energy into depicting it into stone art. That's as far as I got. But then, I started messing around with this. I think I found something on Blue Sky where someone just posted a random medieval art picture, and I saw these like headbutting goats, and I was like, what is this? And I ended up with Isidore de Seville, who was the first person who tried to write an encyclopedia. A lot of the medievalists are so silly stuff we have comes from this person who was like, dragons are everywhere. And they also have these two quotes, one of them being sheep headbutt because they have itchy worms in their head. And I was like, well, I have to include that because that's incredible. Also,
how else would you itch the inside of your brain?
It's a pathological hypothesis, though,
right. Yeah,
in like the 1200s. And then ibex jump off of mountains and land on their horns to like absorb the shock. And I was like, that is a headbutting hypothesis. And so I kind of, this was very fun for me, but technically I think it should be part of the conversation.
Yeah, that was my favorite image, by the way, that you include, was the ibex stuck into the ground.
Horn first.
They're so excellent. And the thing with the illuminated manuscripts is a lot of them are just copies of that same language. And so you have lots of variations of this, like different kinds of headbutting and like the artistic flair that they put into it. I kind of just want to change my job and go be a medieval illuminated manuscript like researcher because it's so fun.
If you can find funding for it, go with God. Yeah, very cool. Yeah, it was tons of fun to read. Like I said, I don't think we should spend a ton of time. I mean, it seems like a lot of work to go back and read all of this stuff and find it, but
I had fun.
Yeah. So, but then figure 5, you have this really nice sort of timeline that shows like a couple of these, let's call them modern interpretations or modern sort of theorizing hypotheses up to the 2000s and like actual citations for papers that are making claims. And you sort of dissect for bovids, bovids include sheep and
bovids are cows and sheep
okay.
and goats, and specifically the ones that headbutt are ovicaprids, but the cow and sheep like animals.
And then woodpeckers is the other timeline. And so this sort of going through a bunch of different papers and what the claims are and like the counterclaims and stuff like that. So that was a super helpful. Sometimes we get into discussions about like data visualization on this podcast, which is hard to do in an audio or video medium because we don't like share the papers while we're recording. But like this is a very nice example, I think, of like dense data visualization. It's data about papers, but
it went through many iterations for sure.
Yeah, not surprised. It's very helpful, sort of like framing the rest of this, and then so you sort of get into now for specific fields. So first you talk about the bovids, and then you talk about the woodpeckers and like specific claims that are being made and why or like where they fall short, essentially. So I'd love for you to just sort of, you already talked a little bit about your 2022 paper, which I was going to ask you about, where you were looking at the brains, but sort of, I would love for you to just sort of talk about the ideas that people had, the claims that they were making, and sort of maybe where they went wrong. Like these people aren't making shit up out of whole cloth, but they're obviously like coming to the wrong. Okay, fair. Yeah, they're obviously coming to the wrong conclusions. So
yeah, it definitely comes in waves as well, and I think that just comes with what's popular in science at the time, and that's why I put both of them side to side, because you can see that there is this parallel of like right now we're all interested in skulls, and then later it's like we're all interested in shock absorption, like kind of in the same decades, but it does come in waves. But like starting with the bovids, I think, and with the woodpeckers actually, because the paper is like half bovids and half woodpeckers, but kind of same narrative of me just being like, hey, where did we start talking about this? And in the beginning, you can see after the history stuff where it's just like, okay, humans have been thinking about this. People start posing hypotheses. Are the gentleman naturalists of around like the 18th century, where they're like, I've observed this. And the trend is these animals are weird. They're, charismatic. They're doing strange behaviors. What is the anatomical reason behind this. And so in both cases, it's probably, well, they have a strong beak. And probably that protects them. Otherwise, why would they do this crazy pecking behavior? And then same thing for the bighorn sheep. They have large horns, very visually. And probably that's what's protecting them. Otherwise, why would they do this behavior? And that's not entirely wrong. Like, yes, these structures do not fail upon impact. They didn't have the tools to know more than that at the time. So like with a skull, here's the research that you can do, right? And so yes, there were anatomical descriptions and kind of just like comments of like, man, this is such a weird structure. Probably it helps, absorb the shock. What happened over time is that there started to be kind of like a fork in the road of people who stuck to the kind of evolutionary component. So I'm going along the lines of Valerius Geist, who's a very famous North American naturalist. He went and lived with bighorn sheep for 3 years. I've got fun stories about him as well. But he kind of I want to say 1960s, he was like, clearly the horns are a visual like metric between males to tell who's dominant so they can avoid a fight. That's why they're so big. It wouldn't make sense for them to be the thing that protects their brain because females have tiny horns, they still headbutt, and there's lots of other reasons why this wouldn't make sense. Except some people still follow this, and then it started branching off where people who were looking into this for engineering, and I'm sorry to the engineers in the audience, I've been on an engineer bashing kind of time, but and coming from a family of engineers, but engineers aren't necessarily good at biology. That's not their field, and they're not going to do the in-depth research because they're not crazy like me about this topic. So they take the kind of what's most obvious without the biological background and run with it, which is the horns are shock absorbers. Anyway, here's a helmet. And I guess at one point, and the same thing for the woodpeckers, the sentence got picked up of, this is shock absorbing. Don't worry about the rest. Nobody ended up proving it, but we picked up on it, and then it kind of just went and ran with they ran with it. And that led them to like more and more in-depth like research on the bone structure, the keratin structure of the horns, and then they kept like aggrandizing the claims of like, this is protecting their brain. They don't get brain injury. It's magic, quote unquote, magic shock absorption. And it comes from a conscious or not creationist mindset of they were designed, because it's engineering, they were designed to absorb shock. And as this kind of snowballs, nobody has looked at if there is brain injury, which I feel bad for centering myself in it. I looked eventually in 2022, but until like this had gotten huge for me, huge. No one else probably has heard about this, but in 2022, this had gotten huge of like, they don't get brain injury clearly. And I'm like, did we look though?
I mean, the narrative around CTE and football players, I feel like was huge.
Yeah.
And it broke through in the culture and like
2015, that's when that started.
Yeah. Football players like committing suicide, donating their brains to science.
Killing people. If
Yeah.
You remember.
Yeah.
Yeah.
And hence, the reason we need to have better helmets. We need to look at shock absorbing materials. Where better than to go to biology? And there is this kind of internal feeling of like, if it's animals, it's perfect, surely. And that is kind of a little bit creationist, a little bit engineering of like, well, it's designed, so it must be good.
Well, it's that naturalistic fallacy, right? That if it's natural, it's good.
And it's also retrospective thinking. And this is something that, going all the way back to my PhD, like I remember my PhD defense really well because it was a bit of a traumatic experience, I think, leading up to that, right? Like I think that is the natural state of things. But I remember getting my thesis in front of everybody, and by and large, it went really well. Like we had some really good feedback up until that point, and somebody made a comment at some point, and it was, I think, probably the only like really truly negative comment that was said, during the actual review of the document, which is, there's a fair amount of retrospective thinking in this. But I think that the work is really good and all of that. And that really took me by surprise, I have to say. Like that was not a feedback that I was prepared for. And I looked back and it's there, of course, right? Like I was a young scientist, and what you do is you observe a thing. You find something that seems reasonable. And then I think as humans, one of the things that we do is we build this kind of logical backstory that fills in the gaps as to why the thing that we saw is now correct. And I see that, playing out a lot in your narrative, right? So it may even be and I think you point to this a couple times, it may even be that some of these animals do have some compensatory mechanisms in
To a certain
place.
extent, yeah.
But that doesn't mean that the skull is capable of, rendering your brain impervious to injury, right? And just because you see a difference between the skulls of these animals and the skulls of what you'd expect in a human, like that you've not found causality,
Yeah,
right?
and
It's
it's
not
hard
even
to
come
be
close.
like, it's just a vocabulary problem, almost in a sense, because it's just, I'm bothered with the way that you're saying it's designed or it's been, perfect or impervious. And I'm like, if you just tweak the vocabulary, this would take on a whole new meaning. But it's like the thinking and then the way that it's written with the vocabulary.
I mean, this is a pretty constant theme on our podcast, which is that like the way that you describe a thing
Matters.
like can take on a life of its own.
Yeah.
Like we talk about this in terms of like immune cell subsets. Like once you define a cell to be a particular kind of cell, it like puts into your brain all of these ideas about what it is.
I could see that.
But yeah, I mean, it's very clear in this way, and I like you do have a little section where you talk about like the parallels with creationist language, and even like citing a like legitimately
like
creationist.
I uncovered a conspiracy theory. I feel like when I found this, I was like, holy cow, this guy is like deep.
It's wild.
I don't know if you looked at his Google Scholar, but
I didn't. No.
So there's like the woodpecker is designed to absorb shock, and then the next one is the physics of Noah's Ark, and the same conference, which is the International Conference of Creationism. So I was like, I'm not even reaching.
Is this PubMed indexed? Is
Google Scholar. I mean, yeah.
That's wild.
I especially liked the tongue argument in Wood.
Okay, I need to talk about
I
the
wanna
tongue.
get to
Because
this
it was my
people come
favorite.
up to me all the time and they're like, "Oh, you study woodpeckers? Do you know that their tongue wraps around their brain?" I'm like, "No, it doesn't," and I don't know what.
literally false.
I need to talk to you about this. Yeah, and this came out of nothing. I mean, it's not. Yes, their hyoid apparatus wraps around their head, and that is
What is a
weird.
hyoid apparatus?
It is the bones that make up the hyoid, which are connected to the tongue. And we have it kind of up in the top of our throat. In woodpeckers and hummingbirds and other birds with really long tongues, it starts kind of, and the throat wraps around the skull, not the brain, because if it wrapped around the brain, that would be an issue for lots of biology reasons, and like goes through the nostril to the tongue. So it is a very strange anatomy, but it also exists in hummingbirds. The point of it is they have really long tongues. In woodpeckers, they use it for insectivory. They eat bugs. In hummingbirds, it's for nectarvory. And they need a place to store it. And birds are because of how they have to fly, the balance of where organs are stored is very important. So the skull is a good place for this. Of course, you see, again, animal does weird behavior. Animal has weird anatomy. Probably they're related. I've dissected a woodpecker hyoid apparatus. It's so thin. It's like a little hair. There's no way that that's doing anything. But it looks cool, and engineers were like, this is a
You can call
slingshot
it a seatbelt.
seatbelt, and it
And
just
then-
kept snowballing from there. And like other engineers read other engineers' papers, and they're like, actually, this is a shock absorber slingshot thing. And I was just like, guys, like, no, stop. And it gets blown up also by popular culture, and I will blame a little bit the interviewers for popular science media who sometimes take one of these things and we're like, the scientists didn't even make a big enough deal about this, and then like blow it up even more. You see all the headlines are like, bighorn sheep heads are gonna solve our lives, and like I'm just like, we need to chill, because where's your evidence?
So this actually brings me to my favorite quote in your paper, which goes back to those
You've had a couple
comments.
favorite quotes. I just want to flag
whole
that.
thing.
Matt.
Yeah, that's okay. So this one's the direct one, which is going back to that page 13, where we're now talking about the scientific field's response to a publication that basically has solved the woodpecker problems. There's a discussion as to what bits of woodpecker biology and anatomy make it so that they don't get headaches. You quote from that paper, clearly the woodpecker's brain is protected somehow from impact and vibration injury. And so, this paper gets published, and scientists in 1976 rightfully feel a bit like maybe the data was weak. Perhaps they didn't go into this. And so this is a letter to the editor of The Lancet. Replying in March, Potter is rather skeptical. Quote, "Your referees must have a difficult task. May I ask you 3 questions? 1, how do these ornithologists know that woodpeckers do not get headaches? What is the size
They're not
of the
taking
subdermal
Advil,
space?
Matt. It's obvious.
Right, exactly.
Can't ask him.
And third, should not some sort of beak be incorporated into the proposed new crash helmet?" I love the snark and contention that plays out in, you know, these sort of retrospective fallacies.
I have
Again,
so
like,
much fun reading these.
it's such a blast.
Well, and you had a section, I can't remember, I think I highlighted it somewhere, but you have a thing where you talk about how, like, you cite like 14 papers all making a similar claim, and only one of them did anything but look at the skull. Like, they're not looking at the
that's the
meninges,
bighorn
they're not
sheeps.
looking at the muscle and fascia and like all of the other stuff.
Yeah,
That's
this is kind of
incorporated
the
into the head and
engineering
spine.
take where they're using like material science, and they're all like the
Yeah.
skull, the skull, the skull. First of all, it makes sense. It's easiest to get a skull. Getting a skull with flesh on it and brains, which is what I have to do, is a pain in the butt. I understand why they didn't get it. You got to make friends with Fish and Wildlife. It's a big deal. You got to get permits. But yeah, claiming there's no brain injury and never once looking at the brain seems problematic to me, a neuroscientist. I don't know, guys. Maybe check.
Maybe you should just
I mean, I think they just assumed that someone had done it and then didn't.
No,
look.
they have a good response actually in that same thing, which is, surely if the woodpeckers got headaches, they would stop pecking.
Yeah,
I'm sure
and
that they
people
don't.
repeat this constantly, and they're like, "Well, of course they would." And it's like, you got like, come on, now we're talking around a beer. We're not writing a scientific publication anymore. Yeah, and that May '96 paper has really blown up because it was published in a like medical journal as a one-off, kind of like, hey, this is so weird, guys. And then it got the Ig Nobel Prize in 2022 in combination with a like Christmas like intro letter from Schwab. I don't know if you saw that one. It's like half a page, and it says like, man, this guy published some crazy shit back in the 70s. They got the Ig Nobel Prize, which I'm a huge fan of the Ig Nobel Prize, but
It's fun.
in this instance, the science was not valid. And then, of course, there's a huge blow up of social media because not social media, but popular media, because they love the Ig Nobel Prize as well, because it's so great to write a headline about that. And now everybody thinks that, you know, they have the tongue thing that wraps around their head. And I'm like, actually, I think they get brain damage, but I need 10 more years to prove it.
Yeah, and this is the Q collar thing that Matt was talking about.
Yeah.
And you said this isn't your particular hobby.
I mean, I
horse
still have
entirely,
problems
but,
with it.
But I would love for you to just like say a few words, because like we're talking about this paper a little bit in jest. I mean, it's fun and it's a neat topic, but also I think like this sort of gets at why it's actually important.
Yeah.
It's dangerous.
I have a
That there is
paragraph
this
at the end that, like,
misinformation.
yes, this
Yeah.
is silly, but it's also really serious. And
Exactly.
so the basics of it are, we know there's a concussion problem. The NFL knows there's a concussion problem. I mean, concussion, traumatic brain injury, chronic traumatic brain injury, ultimately death. There have been cases of a 17-year-old football player with CTE. I'm at a big football school. Like, they're aware, and they think it's bad. Even everybody knows, okay? And so there's a huge drive to find products to make this problem go away, because they're not going to stop playing football, and they're not going to change the rules. So it would be so great if we could just have a magic fix. In comes things like the Q collar, and I don't remember what year they decided this. The science that the Q collar is based on is pseudoscience. I will say this, period. The two papers, there's like a few different that it builds off of that this starts with. The person who published the first paper is, I believe, a pediatrician. And the gist of the paper is, man, I feel like, again, I don't want to get sued by this guy, but I feel like he just smoked a joint and was like, bighorn sheep live in altitude, really high in altitude. This probably, because pressure is higher when you're in altitude, probably their blood vessels are like compressed or something, and they hit their heads and they don't get brain damage. Again, nobody checked, but none of my business. So probably if we just put pressure on our veins, we don't get brain damage. And I'm like, as a human doctor, you should know that, first of all, the amount of pressure that increases as you go into altitude, you'd have to be like 10 times past our atmosphere for it to do anything to, like, quote unquote, cushion your brain or bubble wrap your brain or whatever. And putting pressure on your jugular and your artery when you're playing a contact sport, maybe not a good idea. I don't know. I'm not a human doctor, but like maybe. Anyway, they come up with this product. So the Q collar, and you see it in, if you watch football, which I can't, if you see it in the NFL, and I think we have someone on the team who has one, it wraps around the neck, it puts pressure on your jugular and your artery. The idea being to increase the pressure around the brain to like cushion the brain. The science for me, and this is not science.
Nonsense.
It's FDA approved somehow. FDA approves a lot of like not super good stuff. They have done trials, but they never tested for a placebo effect because I don't know if you guys have ever like worn like, I don't know, like a knee brace. It's the physical sensation of having something like that on makes you put less pressure on it. Or they haven't run trials like, what if you have this magic collar and you play football harder? Maybe you get more concussions. They didn't run this type of science. I've looked at all the stuff they've done. And they're $1 million industry. And, you know, of course, the NFL takes this like, yes, this is a magic fix. We're totally protecting our players. And, you know, NFL, if you're upset about this, like, call me. Like, you know, we could talk. But, and it's the same thing, I think, with the Guardian Cap. I think it's good. Like, they're saying it reduces, you know, brain injuries, sure. But really, ultimately, maybe stop hitting your heads together. I don't think there's a magic fix of this collar. And what they're saying in the papers, it's really like, it blows my mind how much it's pseudoscience. Like, they invented anatomical structures that don't exist and ran with it. They're like, yeah, bighorn sheep, they have a thing in their neck that like, or no, it was woodpeckers, I think. It shunts the blood to their brain. And we don't have that. And if we just have this Q collar, it would give us that. And they kind of use this imagery. We would be like powerful, like a bighorn sheep. It's also very like virile, I think. It's very like, we're big and strong and football. And none of it is even real anatomy. That's the part that really worries me. If you had taken something that was at least somewhat grounded in truth, I'd be like, okay, I kind of see where you're coming from. Not even has it not been experimentally tested. It just invented anatomical structures that don't exist in any animals. So I'm like, what are we doing?
Yeah,
and you can see on their website, they're like, this is bighorn sheep, and then they change it, and they're like, actually, this is woodpecker anatomy, and it's just like bullshit.
Yeah,
sorry.
And so that's an important point, because this is something that I wanted to bring up around this, and I think that it's everything that you just said is completely fair. I wonder if we're giving them too much credit. I wonder if the Q collar was originally designed as a neck brace of sorts. Right, because somebody thought like maybe if we stabilize heads, right?
And then that's
they're like,
a good
well,
point.
actually, that maybe isn't what. But what if we painted a picture where this thing was doing some other physiologic thing? And so what's actually happening here is your field is functionally being usurped in order to justify this nonsense product that has been, you know, it was probably already under development.
And in
you're
fact,
like, oh yeah, woodpeckers, definitely.
The field is
right?
like
what if they
almost
had this
non-existent
thing?
because everything is based on fake science. And I sound like so jaded, but read the paper, you'll understand why I'm upset. I'm like, there's really cool science to be done and you're not doing it right. But also, when I said like I feel like I uncovered a conspiracy is like a lot of the people who branched on this like graph that I did where like some people branched towards evolution and some people branched towards material science. All of the material science people who are very adamant about this definitely protects you, they all have patents on the specific thing that they researched, which is not based in science. And I'm like, crazy how that works. Like maybe they have an ulterior incentive that's not actually driven by science. And to bring it up back to this, one of my favorite figures, I think, is figure 7, where the woodpecker is summarized down to a series of spheres. This is like the running physics joke, right? Like imagine a cow, but it's a sphere. And they literally did this with the woodpecker, and they're like, if we just make it into spheres, it's basically a hammer.
Let's be totally fair. Let's be totally fair. There are some ellipses and some springs. Okay? There's some springs in there too.
I sent this to my dad, who's an engineer, and he's like, I don't see the problem with this. And I'm like, yeah.
I mean, sure.
Do you guys know the sort of fake conspiracy theory that the birds aren't real?
Yes. Which is an anti-conspiracy theory conspiracy theory. Which
No, it's great. There's We don't need to get into it, but it's basically the idea that all birds have been killed and replaced with surveillance drones, essentially. But I feel like when I was looking at this woodpecker diagram, I was like, "Oh, is this the design for one of those surveillance woodpeckers that are?"
Well, and I think that this is a recurring problem in this sort of pseudoscience space, right? Which is if you abstract a problem down to details that basically completely lose the context for how this actually happens. Like, this might not be an inappropriate physics-based representation of how a lever hits itself into a tree.
Yeah.
Right? And you could even find, I'm sure, people to defend that, but you've abstracted the problem down to a place where it no longer in any way represents what the biology of this would actually look like, right? And I think it becomes really hard at that level to parse out exactly where this kind of thing goes wrong, because you've pulled away all of the variables.
Yeah.
And I think you do a really good job in the paper of talking about the fact that dry skulls are dry skulls, but there's a lot of meat. There's a lot
there's other stuff.
Right, there's a lot of stuff there, and by pretending like it's not, pretending that these are all rigid structures and they interact exactly the same way, is inappropriate. You miss essentially the whole point.
Well, and I actually wanted to ask about that in particular, which is like, there are several different levels at which you can do science. So one is sort of the observational. I think that the work that you described, where you like actually go look at the brain of a thing that is doing headbutting and saying, like, do we see evidence of brain injury? Oh, look, there is. And I was sort of curious about, you could imagine, for example, like you were saying the females also headbutt, which I didn't realize, but I was going to ask, like, could you compare like males to females that are doing less headbutting and see if there are differences? Could you compare, like if bighorn sheep or some related animal is raised in a domesticated setting, do they do less headbutting? Can you like compare them?
You're exactly on the right path, because this is what my lab does now.
Oh,
we're like, okay,
cool.
We're not going to bring domesticated sheep, but we have goats. And we did when I started here, we did a 6-month pilot study, just letting goats do their normal headbutting and see what would happen. I'm working on publishing it, but they get brain damage. Surprise. Not a lot. They were really young, but like, seems to be part of their biology. I do want to go back to what Matt said, though. And I want to be really clear that I actually think it's really valid to look at the physics of headbutting and pecking, to look at the material property structures, and I hope that we can find something useful from it. But if you don't base that actually in the biology that's real, then you risk developing a product that's based on something wrong that doesn't do what you thought it was going to do. So like literally just call up a biologist, just double check. There's a paper that came out a few weeks ago that was a drone, that was a crash-proof drone that's based on woodpecker anatomy. Figure 1 had a figure of the woodpecker and its brain. Human brain. They just stuck a human brain in the skull. Clearly AI generated, but I got so mad because I was like, this is such an easy fix. And you guys now made your whole paper ridiculous. Like nobody, like this is, and I'm sure the drone technology is really cool, but this is a joke now because you can't even be bothered to like look at the minimum. And maybe when I do engineering, I don't do a good job. But we need more interdisciplinary work to make this field actually.
But I don't think you would use engineering to justify your findings, right? Because
we're doing, for example,
you would use engineering to justify evolution, for example.
We're doing mechanical, like biomechanics, to look at headbutting and like how different parts of the skull help like force distribution in the skull. And there is an engineering component, and I'm trying to collaborate with engineering. They're hard to get a hold of, but it makes sense to put these two things together. I don't think it's a bad thing that people are doing this research, and I don't want to like blame them for like seeing something that is objectively very cool and trying to like look into it. But I'm like, you need to have that link a little bit, otherwise you're setting yourself up for failure.
Yeah, I was the point that I was trying to make about talking about like observational, like you're doing observational science, like this woodpecker diagram, like you could imagine designing, like we have to do reduction in science a lot of times if we want to do experiments.
Yeah, like you said, domestic animals,
building
like
this structure.
Yeah.
And then having a sensor in the head that's measuring something about the force, trying different shapes, trying different material. Like you could imagine ways in which this sort of simplified and reduced model could provide value, and you could like take steps to investigate in lots of different directions. And I think that
And
would be
arguably,
valuable
your
work.
outcome would probably be better.
Yeah, exactly. I think the problem here that you're identifying is that, like, doing the simplification to give like a gloss of scientific rigor, but then not actually doing
Yeah,
the
you want
rigorous
to do
science. Just like,
interdisciplinary work? Do the interdisciplinary work. Don't just be like, oh, we discovered animals. We're such good engineers. Like, there's a whole field that actually already does this research. You could just ask. And it sounds like I'm like, oh, you guys have to work with me.
pulling
No,
up
I
that
just
hate
really,
draft.
yeah, I really like think that this field has a ton of potential, and it's getting wasted on speculation instead of like actually doing the research. And there's a paper that just came out last week on how. So great, because it was a woodpecker paper where they don't talk about brain injury, and I was so happy. They just look at all the muscles of the body and how they contribute to pecking, and it's like the hip muscles, the tail muscles, and a lot of things contribute. And my favorite part, the way that they breathe is kind of like when tennis players grunt, and how it like gives more force into the hip. They do that too, and they're like micro grunting for all their pecs. That's awesome. Like,
super
you
cool.
didn't even need to think about brain damage to think about that, and so. I'm like, there's stuff to be done here, but we're only now, since 2020, realizing like all the actual research we need to do until we can decide if they get brain damage or not.
Well, and I'm going to drag this into immunology here now that
Please, yeah,
we've
let's actually
discussed
do
this
the
enough, because-
subject we're supposed to talk about.
No. I think that this is absolutely wonderful, but I think it goes exactly to your point. By taking this at the level of biological complexity, we can find like real questions that might actually have an impact on human health, right? So, chronic brain injury, as you mentioned, is a real thing that we're dealing with in human beings. If it turned out to be that, for example, woodpeckers do get traumatic brain injury, right, or chronic brain injury, let's say that there is some level of adaptation in wound healing responses, which we have seen before in immunologic settings. Like maybe there are interesting repair mechanisms in these animals that in some way do limit long-term damage. We don't know that to be true, but it could very well be that you've got adaptations within the immune compartment that have the capability of responding in interesting and unique ways in these animals. Now, maybe that's true, maybe it's not, but we certainly won't know the answer to that unless we actually look at the real biology and ask the question, like, how are these animals' physiology handling this? Is it the same as in people? Is it different? And if it's different, then is there something to learn? Can we apply to this?
And if you assume that off the bat that's not the case, you miss that entire field of research, and it's a very good point. And maybe you guys will have tips for me, because that is exactly what we're doing in the goats. And so in the goats we had like some domestic goats, and in woodpeckers we're doing wild caught, and we do blood samples. And what we're trying to do is throw everything that you can throw at diagnostically at a human, other than like questions, on these animals for non-invasive samples if we can, to see if we can detect at what point, how many times you have to hit your head to get a brain damage. You can't do that in humans. You can't do that in mice. Well, you can, but you artificially induce the brain injury. So if they are really giving themselves, well, you laugh, but that is kind of how they give them brain injury. They just drop weights on their head, and it's not super natural, I want to say. So my like whole like trying to get my NH grant is like, okay, goats give themselves brain damage. Great model of natural accumulated brain injury. If they do this over time, how many times do you have to hit your head? Should we have new like rules in sports to stop at 10? Once they do start developing chronic injury, can we develop an early intervention in the cerebrospinal fluid, in the blood, where we can see, so this is where you guys come in. I don't know what we're supposed to be looking for in terms of immunology. I'm looking at GFAP, which is an astrocyte marker, S100B, another astrocyte marker, phosphorylated tau, a protein that can occur in blood and CSF when the neurons start to degrade. Markers that we kind of know well for brain injury and to a certain extent Alzheimer's disease.
So maybe it'd be worth just talking a little bit about neuroinflammation. I mean, it's not my like primary field, but I think there's sort of a couple of different components. So to what we know about damage that happens in the brain that is either related to or caused by the immune system. So one thing is just like if you get damage to the meninges, whether from like blunt force trauma or whatever, you have like physical damage to tissue, you are getting sort of typical repair pathways happening. These are often associated with inflammation. We've talked about this on the podcast before. Wound healing tends to be a non-inflammatory process, but oftentimes you get danger signals that get released. You get some amount of inflammation happening. You also have these proteins that are that can accumulate. These are mostly associated with things like Alzheimer's and other kinds of dementia. But you have these sort of protein aggregates that are formed, and one thought is that the macrophages that are trying to consume these aggregates are there's a couple of different inflammatory pathways that are involved. Like when you have a macrophage in the brain, these are called microglia, sorry. When they try to wrap around large physical structures, these might be like aluminum salts, they might be uric acid crystals in gout, for example. It damages the endosomal wall, and that triggers inflammation in these macrophages through a couple of mechanisms we don't have to go into. But there's similar things happening potentially in the brain. Can you say a little bit about what tau is and what phosphorylated tau is and how that's related?
Yeah, and I like your explanation because I skip all over that part, and I tend to over laymanize, and I'm like, all right, you hit your head, your neurons and potentially other brain cells will physically rip apart, which causes inflammation, and you heal from it. And that's what usually happens if someone gets a concussion. If you, say, play a physical sport like football, or like me, roller derby. Why did I start a contact sport? I don't know. And you hit your head very frequently, your body constantly stays in this kind of activated inflammation stage and doesn't have a chance to start healing and clearing out debris like the plaques that you'd see for Alzheimer's disease. What happens with phosphorylated tau? You have microtubules, which are essentially the cytoskeletal structure, like the skeleton of your neuron. When the neuron physically rips apart, it breaks apart and releases these tau proteins, which actually were kind of holding this skeleton together. And they end up in the bloodstream and also clogging up, quote unquote, areas in the brain, and can, form these accumulations that we can detect with antibodies, which is how we figure out that they have brain damage. The reason we can tell it's brain damage and not just random aging, because this does happen with aging, is they are in specific locations. So there's a very specific pattern for, CTE, because that's like the most extreme case. In humans, you can see it with the naked eye when you do an immunostain. You can cut a whole hemisphere and see that at the sulci, so the folds in the brain, at the bottom of the folds, there's these big brown clumps of, because with physics, when you hit your head, the force kind of ricochets in between the gyri, ends up at the bottom and just tears all those cells over and over and over. And so a lot of the damage is focalized in those areas, and also around blood vessels, because the blood vessels act kind of like cables in a jello. If you shake the jello, very visual image of just tears all around it. And so that pattern would not come from anything else. And that is what we did see in the bighorn sheep, and specifically in the muskoxen. And you see kind of this tau. We use tau as this marker because it's from, degenerating neurons. It's easy, quote unquote, easy to stain for. Really annoying if you don't work on human and mice to get the antibodies to work, but that's your specialty.
Do you have, is there any way to see it like with contrast or anything else on an MRI or a CT scan?
So with CTE and chronic TBI, by the time you see it on an MRI, you already have behavioral symptoms that are really advanced. So like you're in the late stage, and because the only thing you see is shrinking, and by the time your brain is shrunken, you've lost so many neurons that like you're really late. It's the same with Alzheimer's. Like if you can see it on the MRI, that's like a bad red flag. However, people have been working with PET to find PET markers. And we actually did PET on our goats, and still, again, working on publishing it. Once again, of course, because I'm working with weird species, really hard to get markers that work. For example, stuff that works in humans and mice, for some reason, didn't pass the blood-brain barrier in goats. I don't know why. But there are specific tau PET markers. They don't work really well. We're still working on it. But there's other things you can look at. There's amyloid beta markers, like that Alzheimer's plaque protein. We looked at, you can tag the inflammatory markers. So with this radioactive PET, you have to still be pretty advanced. PET resolution is not very high. And the plaques that, we would see are microscopic. You can't see them with the naked eye. So you can't see them on PET. in humans, again, once you're advanced, you can see it, and PET will catch it before, MRI shrinkage. There's also things like cortical thinning that you could catch, but like the best way to catch it, unfortunately, is to look at a piece of brain tissue, which in humans we're not going to do. And so all the money right now is on CSF, or ideally blood markers, biomarkers that you can get while people are alive, and it's non-invasive. It's getting there. People have started, I think Sinai last year started doing patient blood biomarkers. They're not great. The signal's not super strong. It's pretty variable, depends on what kind of analysis you do. At least I've also found the CSF is pretty reliable, actually. And we got, with our goats, we actually got increasing GFAP, so astrocytic markers, over time, and with increasing headbutts. So that's my one significant data. Woo! Nice. And then like the tau and stuff didn't increase over time. It was only a 6-month pilot study, so I wouldn't have expected.
Are you literally just like filming the goats and counting the number of times they butt heads?
Oh, yeah, all my undergrads. So we're working on an automated counting system for that, but because we have to prove that the counting system works, we need to do a manual count. So next week, I think, or in 2 weeks, we're having a LAN party where all my undergrads and me are sitting together for 12 hours, and we're gonna count headbutts all day. I think I'm gonna live stream it because it's so ridiculous. So if you guys want to tune in for that.
Yeah, we should
we do have to manually count that, and it's a giant project because we're doing video camera, looking at behavior changes, headbutting, CSF measurements over 6 months every month on goats.
Wow.
Blood draws every month. We put accelerometers on them to see how hard they were hitting their heads. 2 Gs to 12 Gs to 20 Gs, not too bad. What else did we do with them?
It's a lot of Gs.
Saliva.
20 Gs is plenty.
Yeah, we did
enough.
saliva measurements. We basically, like I said, we threw everything at the wall, and I was just like, let me collect as many specimens as I can and see what we can measure. So
totally. Do we know how hard humans headbutt in football?
We know that about 100 Gs is where NFL calls concussion, and that's concussion like blackout, which is the most severe. Subconcussive impacts, I think, are where most of the problems happen because there's so many and they don't really quantify those. And it's kind of hard to say if it's doing anything because, again, we can't, like...
So no one stuck accelerometers on football players' helmets?
Yeah, they have accelerometers, I think, in their mouth guards sometimes and in the helmet. And so that's how we kind of know the forces. But unless they pass out, it's kind of hard to say if anything's happening unless you immediately take a blood draw. And I'm sure there's people that are working on this.
I'm curious, like, what is the like typical range of force on just like a normal snap, like normal play?
I've seen it go from like 20 to 100 in some of, again, this is in the NFL data, and sorry NFL, I only kind of trust that data. And also they don't really share all the good stuff. I'd be happy to work with them though.
This will be a good pitch.
Yeah.
Get your school's IRB to put it in your players' helmets. Like
they have the data,
never going to go for that.
But I'm like, I don't think they want to talk to me because what am I going to say? Like, maybe don't play football. Sorry.
Yeah.
I have a student, like I work with a student who's on the team, and I'm like, please just do neuroscience and stop playing football. But he's really good.
So I mean, in all seriousness, so at Emory, where I am, we have a physician here that is responsible for the medical care NCAA football teams, and he was here, and there was a real legitimate discussion around exactly that, around if you are a physician caring for these 18 to 22-year-old men. What is the ethical obligation there?
Depends how much you love football.
And I think that there is robust discussion, I think, to be had around that. It's unfortunate that it's hard to have an academic discussion.
And I understand
because of the financial forces.
People
involved.
love the sport.
Sure.
I'm also in a sport that I love. That I'm like, well, if I get a concussion, it's fine. And I get it. And I think the players, to a certain extent, know what they're getting into, but also their prefrontal cortex is not fully formed. And then it's just, we've just accepted as a society, it's a gladiatorial sport, and we're okay with that, and we're fine. And the people who play it are fine with it if they go down in infamy. And then we have things like, we used to have this player, Tua Tagliova, I think. He's in the Dolphins now.
Yep.
He's had 4 on-screen severe concussions, and I quote unquote like say this, I don't know, this is a bit inflammatory, but I'm like, if he donates his brain, I know exactly who's getting it, because there's one CTE lab in Boston, and they do all the severe CTE cases, and he will be on that list. I don't know if he's going to donate his brain, and I think he's very nonchalant about it. And I don't want to speak for him. Like, he's made his decision. He doesn't seem to care. He's like, I'm just going to play. I play really well. And if I get concussions, I get concussions. And like, that's your decision. But yeah, at what point are you like, man, that's a crazy decision. But yeah, it's sports. There's other people that do more dangerous sports where they don't go on the concussion brain bank because they die on impact. So
jumping off cliffs with the wingsuit.
Yeah, or stuff like Formula One, or even competitive bike or horse riding. Like, if you fall, you die a lot of the times.
Well, and I think you're right to point out that at some level, there has been an understanding and acceptance of this for a long time. It's not as if people have not observed that boxers that have carried out full careers functionally don't operate well on the back.
Yeah, and this is
life.
really interesting to me because it's innate to us, and I think this also feeds into my paper, which is what why I was questioning like the history of thought, because we all know, like, kind of intuitively, just from absorbing this information, that like, oh, boxers get brain damage. Like, we don't even have to think about it. And we get the same thing when we think about bighorn sheep and woodpeckers. A lot of people will be like, oh, they're immune, or like, yeah, they're protected from their tongue. And it was so interesting to me that, like, why do we like consciously just kind of be like, it must be that, and without even thinking about it. And so I think that's a really interesting, we just kind of make those associations and don't really dig into them. I just like have a pathological need to prove people wrong. So
I mean, used to very good effect, I must say. We can get more into this. I just want to hit a couple more things before we finish recording. First, there's a section 3.4, other head-hitting animals, where you did a lot of lovely alliteration.
Yep.
Thank you. Thank you for noticing.
I very much appreciated the dueling dinos section because my son, less so now. Now he's into big cats, but he had a chunk of time where he was really into dinosaurs, and we were talking a lot about the pachycephalosaurs and their thick skulls. I think one of the books he had said that their skulls were like 12 inches thick. Is that true?
Yeah, so those domes are actually the part that we mainly find from them because they're so massive. The domes are bone all the way through.
Yeah,
the fact that they went extinct maybe meant that this wasn't a great strategy. I don't know. But yeah, it's insane. And I don't
think you can blame that. I don't think you can blame that on other things were going on for the dinosaurs.
I have
one. Whoa.
I think this is I'm not good at paleontology. It's one of the really cool ones.
For the YouTube photos,
For
the listeners.
For those listening, I'm holding up a tiny mold of a 3D printed Pachycephalosaurus skull, and you can see the big bony dome on the top.
It's very cool. Yeah. It's wild. I also wanted to say that in the clashing cetaceans, not quite alliteration because it's the and
I tried.
But that's fine. It was close. It was good. I just wanted to point out they have a large organ called the junk, which I thought was pretty wonderful. Never heard of that before. Can you tell us what the junk is?
Yeah, so sperm
I'm looking
whales...
for titles for the podcast.
Oh, yeah.
Tell me about the junk.
Yeah, I mean, there's lots of head and butt jokes that you can make also. Also, hey, I got fuck into the paper. I don't know if you noticed that. I'm very proud of this achievement.
Did not.
And figure 1. But I'll tell you about the junk while you look for that. So sperm whales have this giant organ at the front of their head, which they used to be hunted for because it contained good oil for lamps. And this is called the junk. Nobody is quite sure what it does, but the males have a bigger one. They do headbutt. If you've heard about Moby Dick, he headbutts a boat and sinks it. The males fight this way. And so one of my kind of comments is they headbutt. Is it, a secondarily evolved behavioral trait? Is it a set artiodactyl, as in like their common ancestor headbutted? People hated me for saying this, so I don't know. I don't really care, actually. I also, in one of my previous reviews, have a picture, first published ever, from a colleague of 2 bottlenose dolphins jumping out and headbutting in midair. So all of the whale families headbutt. Whether that has an impact on their brain, I don't know if I'll ever find out because the paucity of this tissue. And honestly, I've done a lot of staining on whale brains in my postdoc from this colleague who had a fridge full of brains. And it's a pain in the butt, even more than goats. So I probably don't even want to get into that because the brains that you get are like washed up on a beach. and
So
like all
interestingly,
gross,
and I don't,
but
I can't promise anything.
maybe they
but
get brain
interestingly,
damage.
interestingly, I have a brother who's a dolphin trainer at the Georgia Aquarium.
Hook me up.
Now I don't know what their procedure is as these animals die, but if you'd like, I can try to put you in.
There's a network.
Patrick, let me know
believe
if I should cut this section out.
Yeah, it's ethical. When the whale shark died, I immediately called up my shark friend and was like, "You getting the brain? What are we doing?"
Okay, so you're already tempted.
So I think people know, and there's definitely people that are in link with that. But I mean, I'm not well equipped for dolphin brains, and I think it would be better used at a dolphin lab. I think North Carolina has a really good Wilmington, North Carolina has a great marine science program, and then Sinai also gets a bunch. There's way more whale strandings than you'd think, and they get a bunch of brains that way. So
Wild. Yeah.
the dolphin people are really
I
intense.
found the fuck. It doesn't come up with Control F because it's in one of the comics.
It's in the comic. That's how I got it through
Nicely
peer
done.
review.
Nicely done.
Actually, my reviewer said I saw it and I didn't say anything. Yeah.
Fantastic. All right, so I think we said this already. It is really worth your time to read this paper. It's not hard because it's not like you don't have to
tried to
slog
make it
through facts
accessible,
plots.
yeah.
You don't have to wade through like mouse models with like a bunch of different genetic crosses.
It is long.
It's just like it's long, but it's totally readable.
It's like book long,
and
that's okay.
Yeah. It's like a good article from the Atlantic or something.
Yeah.
And I think the framing around like here's the history, here's where things went off the rails is really useful. And like this thing around CTE and the sort of the problems inherent in sort of taking these ideas uncritically to make money. I was reflecting on this idea. So in the microbiome, there was this phrase that people used because it sounded really cool, which is that there are 10 times as many microbes in your body as there are human cells.
I've heard that, of course,
This phrase, like every single microbiome talk for like 15 years started with this slide. Mm-hmm. And then somebody was like, is that true?
Is it?
And they went and they like tried to do the calculation based on this one paper. I haven't investigated the math in detail,
they
but
had
based
the
on this
same
one
problem
paper,
I had.
essentially. But they went and they like went through and they sort of like tried to do an accurate thing, like how like let's actually think about how many cells we actually have. Yeah. And their conclusion was basically like it's more like 1-to-1. Bacterial cells to human
less
cells,
exciting.
and it varies by the last time you took a poop, basically. Like depending on when you last had a bowel movement, it will change the ratio.
Man, that's
of
such
cells.
a
And it was
bummer
like, it was like
slide
from
compared to before.
from 2-to-1 to 1-to-2. It's like
You can open your paper.
yeah,
When's the last time you had a bowel movement?
it's a
in
bummer.
that case?
Exactly. Exactly.
That's the title.
Yeah, there's your title.
No, but that's not related to brains. I'm not going to do that. But that statement, everybody used it because it was cool sounding, but it wasn't harmful. Like it was like it was misinformation in a sense, but it was harmless misinformation. I think the thing that I really appreciated about this review is sort of like doing the fun stuff, doing the cave paintings, all of that stuff, doing the snark, and then being like, but actually this misinformation matters. This actually has real consequences.
I'm not just
there
crazy.
are people making money. And it's not just a laugh. It's not like, oh, those silly scientists. Like it has real consequences in people's lives. People are paying money to get a product they think is going to keep them safe, and it may not. And
Yeah,
it
and
may
they have
be actively
hope.
harmful, as
And
you
it's-
said. Yeah.
Yeah, it's manipulation almost.
Yeah, absolutely. And so I really appreciated that. And like, I don't want to end on a down note here, but I think it's a really valuable contribution.
I think it's a positive note that there is a way forward to improving this. I mean, we're right in the smack dab right now of like the technology that we have. We can find this out. People just need to like read my paper.
Yeah, do the fucking
Get your
work.
background work and then like do your research really well, and I'll be super happy. And you don't have to ask me. You can ask your colleagues at your university who do biology. And then I'll
Or
be so
let's
happy.
fund Nicole so she can do the work.
Or NIH, call me up. I'm
There you
waiting.
go.
Exactly.
Or anyone. What's good in 2025?
Yeah,
NIH,
exactly.
give everyone a call. I'm
Manifest.
glad you're back open.
Yes, gosh.
Any other comments, or should we wrap up and say this has
I
been?
mean, Thanks for liking my paper. I
Yeah.
will never shut up about it. This is like my passion paper. And I don't know if you read the acknowledgments, but they're fun because a bunch of random people just were like, hey, had you heard about this? And have you heard about this? And I just kept adding random weird shit into the paper. It was the
Now
best
I'm going to
part.
go find the acknowledgments.
Yep.
Yep.
While Matt is reading that, this has been Audio Immunity, episode 49. Matt and I are talking about what we're going to do for episode 50. We might do a little like retrospective talking about various things. Or we won't, because sometimes we get lazy. If you like what we do, if you like random digressions into headbutting animals or our normal sort of more deep dive immunology fare, you can find all of our past episodes, links to subscribe to the RSS feed, to our YouTube page, all at audioimmunity.org, AUDIOMMUNITY.org. You can find links to Patreon if you want to throw us a buck or two an episode. Could really help us out. We don't do this for the money, but it is a nice acknowledgement. But as we've said a lot of times, the best way to support is to share us with friends and colleagues that you think would find value. And the music at the beginning of the end is composed by Rachel Rennick.
Thanks, y'all.
And if should I plug?
Yeah.
Go for it. Yeah, please do.
Sorry.
Please plug
If
away.
you want to learn more about headbutting or want to complain about my paper, I'm at nicoleackermans.com and the same handle on Blue Sky. And,
Nice.
go
Yeah,
check it
and we'll
out.
put those links as well in the show description on the website, which again you can find at audioimmunity.org. All right. See you next time.